Hi guys, welcome to Unit 8, Lesson 5, Probability of Chance Events. So with each problem that we're going to go through, there's like made up experiments that happened that we're going to base the information off of, okay? So this is more based on experimental probability than it is on theoretical. So with our first example today, this is number 1 on your practice, okay? It says a farmer conducted an inventory of his 2 square kilometers of rainforest. The results are in the table. He plans on randomly selecting a seedling to experiment on when he goes back to the forest. What is the probability that he will randomly pick a type B plant? Write your answer in the simplest form of a fraction. So, fraction in simplest form. Well, let's see. Plant B, there are 140. So really what we're doing is we're comparing like plant B to the total. Okay, so that would be us using like the relative frequency of it as well. So we need the total. Here's plant B. I'll write it over here. B out of total. So we have 140. If we were to add all of those together, well, let's see. We've got 100. This would give us 240 if we added these two together. This would give us 320. This would give us 380 and then 420. Let me make sure that I added those correctly. It's always okay. I mean, it's good for us to like practice using our brains, but we also want to make sure that we're actually accurate. And for me right now, it's the end of a Friday, so my brain is hurting a little. There you go. Yep, I was right. 420. So the total was 420. Okay, now it says to write our answer in simplest form. So we have it in fraction form already. Woohoo! One thing I noticed is that they both end in a 0, so dividing like 10 would be like to cut those zeros out. So that would give us 14 out of 42. And then let's see. I know that both of those could be divided by 7. 14 divided by 7 is 2. 42 divided by 7 is 6. And then that can even reduce further. Both of those are divisible by 2, bringing us down to 1/3. So your final answer on number 1 would be 1/3. The second problem that we're going to do is number 5 on your practice. Jade tossed a cube with faces numbered 2, 4, 6, 8, 10, 12. What is the smallest discrepancy between the experimental and the expected probability of this experiment? Write your answer in 3 decimal places rounded to the nearest thousandth. So there's a few things that we need to do. Okay, first off, we need to figure out, well, each face has an equal chance of, let's see, each face has an equal chance of being landed on. So the expected probability, right, would be 1/6. Okay? The expected would be 1/6. Now it says write your answer in 3 decimal places. So really that 1/6, we're going to want to convert that to a decimal, which gives me 0.16 repeating. So we're just going to let that hang out there for a minute. For this problem, what we're going to do is we want to figure out, well, first we need to figure out how many times was this die or this cube rolled. Okay, so we'll say, let's find our total. To do that, what I'm going to do is I'm just going to add all of those up. We've got 10 plus 9 plus 6 plus 15 plus 13 plus 8. So total, they were tossed 61, or it was tossed 61 times. So what we need to figure out is what probability, right, or decimal out of 61 do each of these fall under. So let's see, for the 10 out of 61, let's see, on my calculator, I'm going to do 10 divided by 61. I'm going to have to do this for each of them. So let's see, we've got 0.1639 for that one. And then for the next one, let's see, we've got 9 out of 61. If I do that, 9 divided by 61, well, that gives me 0.1475. Okay. And then for the next one, 6 out of 61. 6 divided by 61 is 0.0983. For this next one, 15 out of 61. That gives me 0.2459. And then 10 out of 13, or no, I'm sorry, for the tens, 13 out of 61. That gives me 0.2131. And the last one, 8 out of 61, gives me 0.1311. Okay, so for this one, what we're going to want to do is we're going to want to find the lowest number on here, okay, the lowest number on here, and we will go from there. Okay, so with this one, what we're going to do is we want to find the one that is the lowest difference. That's a better way for me to say it. The lowest difference between this one being our expected probability, and with the ones that we found here. So what we're doing is we're trying to figure out which one is closest to it. All right, so, and that would be this one here. Notice with this, like if I were to expand this, I could say 0.016, and this would keep going on and on and on. But since we're rounding to the nearest thousandths place, I could write it as 0.167. Now this one, I'm going to need to round that one as well. And the reason why I'm focusing on this one is because notice it starts out the same, 0.16. All the other ones are further away, okay, which means they have a larger discrepancy, meaning a bigger difference between them and the expected probability. But with this one, I could rewrite this as 0.164. And so to find the discrepancy between the two, what we would do is we would take, let's see, I didn't place myself very well. There we go. We would take the expected probability, which is 0.167, and then we would subtract the one with the lowest difference. In this case, that's 0.164. 0.164, giving us a discrepancy of 3, let's see, we've got tenths, hundredths, thousandths, okay? Now, I didn't leave myself very much room, I apologize, but your final answer, it says write your answer in 3 decimal places, right? And what is the smallest discrepancy? So the smallest discrepancy is this right here, okay? That is your final answer on that one. And I'm sorry I got a little tongue-tied on it, but what I did, just to recap, was I found the experimental probabilities of all of these, and then I compared them to the expected. I found which one is closest, and then subtracted it, okay? So there was a lot going on in that one, which is one reason why I chose it, was because I knew there was a lot to do, and I wanted you to be able to see that process. For the next one, this is number 1 on your quick check, and let me just get over there real quick. There we go. All right, a spinner is divided into 4 sections labeled as K, I, N, D. Xavier reproduced the wheel and uses a computer to simulate the outcomes of 500 spins. What is the approximate probability that the spinner will stop on a consonant on the next spin? So what they're telling us is that if we added all of these together, they would all equal 500. Okay? And so if we were to find the approximate probability that the spinner will stop on a consonant, well, we need to focus on this one, and this one, right? Those are all consonants. So what we would do is we would add all of those together and put that out of the total, which is 500. Okay? And so let's see, if I do that, I've got 120 plus 105 plus 135. That gives me 360 out of 500. Now I know you're not looking at the problems right now, but all of the answers are written in decimal form. So I need to convert this to a decimal, and how I'm going to do that is I'm going to take 360 and I'm going to divide it by 500, which gives me the decimal of 0.72, and that is the final answer. Okay, so we have a 72% chance of landing on a consonant according to this data. That's one way that you could read that. It just happens to be written in decimal form at this point. I hope this helps, and I hope you have an awesome day. Reach out to me if you need extra support.